Okay, and this is problem 30 from section 1.7.1. Okay, so in this problem, we'll go ahead and graph these two lines and then see what happens. Now, some of you may be able to look at these and already tell what type of system it is. But if you can't, let's go ahead and graph them. Let's look at the first one. An easy point is going to be x equals to 0. Let's see what happens whenever x equals to 0. This goes away, leaving me with y equals 2. So we have 1 point of 0, 2. Let's pick another point. I see here that I have a 1/3 there. So if I pick a multiple of 3 for that x, then that will eliminate the fraction. So let's pick a multiple of 3. We could pick 3. How about that? So let's let x equal to 3. 1/3 times 3 is just 1. So we have y equals to 3. So our second point is 3, 3. Now let's look at the second line, and let's pick 2 points for that and solve. Again, an easy point is going to be letting x equals to 0. So let's see what happens whenever x equals to 0. Again, just in case there's any confusion, you can pick any number for x or any number for y and plug it in and solve it for the other variable. Okay, let's see here. Again, I see that this is a 1/3. If I pick a multiple of 3, then I'll get a whole number rather than a fraction. So let's do the same thing. Let's pick, say, 3 as we did in the first example. We have 1/3 times 3 is 1. This would be y equals to -6. So we have a second point of 3, -6. Now let's graph these two lines and see what happens. On my first line I have 0, 2, and 3, 3. My second line I have 0, -7, and 3, -6. Now, if we keep on drawing these out, you're going to find that these are parallel lines. Now, what you would notice in the very beginning is that our slopes for each of the lines was 1/3. The slope of the first line was 1/3. The slope of the second line was 1/3. This is a good key right here to know that these are parallel lines, and therefore, since they don't ever intersect, they have no solution, and we call that inconsistent.